Hello everybody, good evening to you all. A very warm welcome to Vignan Junior College's channel. I am Aksa, Senior Faculty in Chemistry. Please subscribe this channel. So, before I start the lesson, I would like to give a brief account of what is chemistry, how chemistry is involved in our day-to-day lives. Okay? What is chemistry? It is a branch of science which deals with interaction, properties and composition of matter. What is chemistry? It is a branch of science which deals with interaction, properties and composition of matter. What is matter? Matter is anything that has mass and occupies some space. Okay. Matter may be this pen, this board, anything may be matter. It has mass and occupies some space. Matter may be solid, liquid or gas, right. So, study of matter, chemistry. Then how chemistry is involved in our daily lives, right. The air we breathe, it is a mixture of so many gases like nitrogen, hydrogen, say for example oxygen, traces of carbon dioxide, noble gases. What is the most abundant element in atmosphere? Nitrogen. 78% of atmosphere has nitrogen. What is the most abundant element in the earth's crust? Oxygen. Most of the metals, they are available as oxides. So, what is the most abundant element in the universe? Hydrogen. Whenever you go to like Saturn, Jupiter, Sun, stars, everywhere hydrogen. So, most abundant element in the atmosphere, nitrogen. Most abundant element in the earth's crust, oxygen. Most abundant element in the universe, hydrogen, right. So, how chemistry is involved in our daily lives, that is what we are discussing. See, water, if I take water, water has hydrogen and oxygen in 1:8 ratio by weight. Water has hydrogen, oxygen 1:8 ratio by weight. Whatever may be the source of water, whether it is lake water, pond water, sea water, it has hydrogen and oxygen in a definite proportion, that is law of definite proportions. Next, we are talking about something what we eat. See, different types of food we eat, carbohydrates, proteins, vitamins, minerals. What are carbohydrates? They are polyhydroxyaldehydes or ketones. What are proteins? They have peptide linkage, C double bond ONH2. Proteins have peptide linkage. Similarly, in our digestion also, in our body, so many chemical reactions take place, right. So, in our system, carbonic acid bicarbonate, it acts as a buffer. It maintains constant pH. So, similarly, if I take for example different types of clothes we wear, nylon, terylene, cotton, polyester, silk, wool, what are these? They are nothing but organic polymers. What is a polymer? It is formed by union of simple molecules, organic polymers. For example, if I take terylene, the monomer used in the preparation of terylene is ethylene glycol and terephthalic acid. So, different ways we are using chemistry. For transportation, we require petrol. It is a mixture of hydrocarbons, right. Similarly, we are living in big buildings. See our campus, huge buildings. See how to construct these huge buildings. We use steel, steel like bricks, cement, okay, iron. What is this cement? It is a mixture of calcium oxide, silica, alumina, magnesia, iron oxide, sulfur dioxide, mixture of oxides. So, we are taking different types of medicines. For example, to reduce body temperature, antipyretics. to reduce body pains, analgesics, to reduce, kill or prevent growth of microorganisms, antibiotics, antiseptics, disinfectants. So many types of drugs we are using, lot of research work going on throughout the world. So, without our knowledge, chemistry is involved in our lives, right? So, when I think about chemistry, what comes to our mind? Atom, molecule, ion, electron, element. Tell, what is an element? An element is a substance which cannot be further divided into simpler substances. What is an element? It cannot be further divided into simpler substances. If I take for example copper, iron, we can physically break it into pieces, but we cannot change the composition. So, different elements. So, in this class we are studying classification of elements and periodicity in properties. Our chapter today, classification of elements and periodicity in properties, right. So, when I say what is classification, in general when we say what is classification, this is method of grouping, that means similar things put together, that is method of grouping. Then what is periodic classification? It is method of grouping of elements in the periodic table. What is periodic classification? Method of grouping of elements in the periodic table, may be based on properties, based on atomic size or like atomic radius, atomic number, similarity in properties, electronic configuration. The method of grouping of elements in the periodic table, this is called periodic classification. Then what is this periodic table? What is this periodic table? See, it is a tabular arrangement of different elements in rows and columns. The tabular arrangement of different elements in rows and columns, such a way that similarity appears at regular intervals. At certain places similarity appears. So, this is periodic table, right. Now, now we are discussing what is need of classification. Why do we need to classify elements, right? How many elements are known today? 118 elements are known today, but all elements, they are not officially announced their names. Certain elements, they are yet to be announced their names. Out of these 118 elements, few, for example, around 94 elements, they occur in nature, God's provision. The remaining elements are man-made, they are synthesized. So, to study the properties of this many elements in the periodic table, it is a very difficult task, right. So, there must be some systematic classification. Some elements you see, some elements are gases, some are liquids, some are solids, some are highly reactive, some elements are less reactive. How can we say this is more reactive, that is less reactive? That depends upon valency shell configuration. So, to study the properties of this many elements in the periodic table, it is very difficult task. So, there must be some systematic classification. Now, we are starting with genesis of periodic classification. What is genesis? Genesis means beginning, beginning. What is the beginning of classification? See, in early 1800, Dobereiner, he classified elements 3 as triad. He took 3 elements with similar properties as a group, as a unit. What he observed, the atomic weight of the middle element is the average of atomic weight of first and third element, terminal elements. What is Dobereiner's law of? He gave a law of triads. What is this Dobereiner's classification? He took 3 elements as triad. He found that atomic weight of middle element is the average of atomic weights of first and third element. See here, this is one example we are taking. See here, lithium, potassium, terminal elements, atomic mass 6.9, close to 7, potassium 39. If we take average 46 by 2, it is close to 23. So, what is Dobereiner's classification? He took three elements with similar properties as triad. Atomic weight of middle element is the average of atomic weights of first and third element. But this did not work out for all other elements. If we take some other 3 set of elements, this did not work out. So, this could be for few elements, right. Actually, prior to Dobereiner in 1789, Lavoisier actually he started classifying elements as metals and non-metals, but officially Dobereiner published his classification, right. So, if I take some other examples, just now we saw 6.97 close value. So, atomic weights of first and third element, average atomic weight of middle element. If I take some other examples, see for example, chlorine, bromine, iodine. Atomic weight of chlorine 35.5, iodine 127, average. If I take for example 162.5 by 2 average. So, close value, not exactly, close value. If I take for example calcium, strontium, barium 40, 137, terminal elements, atomic weights, average 177 by 2, close value. To some extent he could classify elements, but he failed in some other elements, right. So, that is Dobereiner law of triads. Next, one more scientist, Newlands, he gave one more law, law of octaves. What is actually Newlands classification? He kept elements in the increasing order of atomic weights, and he observed that at regular intervals properties of elements are repeated. At certain regular intervals properties of elements are repeated. That means what Newlands observed, the 8th element properties are a kind of repetition of first element. Just like 8th note resembles first note in octaves of music, sa, re, ga, ma, pa, da, ni, sa, like that. Observe here. So, just like musical notes, the 8th note is a repetition of first note. He gave law of octaves. Now, you observe. See, to some extent he could classify elements, the then known elements around 56 he could classify. He observed at 8th position properties similar. Lithium resembles sodium in properties. Similarly, we can take for example beryllium, it resembles magnesium at certain regular intervals. So, first and 8th their properties are similar. This holds good up to calcium, but afterwards this type of classification failed because once the transition elements are induced, so their properties are not exactly similar. So, this type of Newlands law of octaves, it worked out up to calcium. He may be asking objective bit, up to which element the Newlands law of octaves holds good, up to calcium. Afterwards, we have transition metals, so their properties are not exactly matching after 8th element. So, this is Newlands law of octaves. One more scientist, Jean Courtois, he studied properties of elements. He arranged them in the increasing order of atomic mass, and he has formed a cylindrical table, but this did not work out well. It did not attract many. So, now what is this Newland's law of octaves? When elements are arranged in the increasing order of atomic weight, right. So, the properties of 8th element is just like repetition of first element. This is like musical notes. It worked out up to calcium. See here. So, up to calcium this could work out, but once the noble gases are induced, if I take for example, if I take once one noble gases are in the 1900 year they were discovered and they were added to the table. Now, see here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, 1, 2, 3, 4, 5, 6, 7, oxygen, fluorine, neon, sodium. So, once noble gases were discovered, they were included in the main table, then 8th element properties are not repeating. That means, with the discovery of noble gases, the everything Newland's law of octaves, the type of classification collapsed, that table got collapsed. So, we are discussing some earlier scientists, their own opinions regarding classification of elements. Now, two different scientists, Lothar Meyer and Demetri Mendeleev, they studied properties of elements independently. They studied properties of elements, right. What is the Lothar Meyer and Mendeleev's, what is their opinion? They arranged elements in the increasing order of atomic weights, and at some places will get repetition of characters, repetition of properties. At certain regular intervals, properties are repeated when elements are arranged in the increasing order of atomic weight, right. What is the main difference between this Lothar Meyer and Demetri Mendeleev? What is difference between Lothar Meyer and Demetri Mendeleev? Lothar Meyer, he took atomic masses and atomic volumes like physical properties. Lothar Meyer, he considered only physical properties while classifying elements, but Demetri Mendeleev, he took even chemical properties also while classifying elements. The difference between Lothar Meyer and Mendeleev is Lothar Meyer considered physical properties, whereas Demetri Mendeleev, he considered chemical properties also while classifying elements, right. So, Lothar Meyer, he has plotted some graphs. He has plotted some graph by taking atomic volume versus atomic mass. He plotted some graphs. See, here and there we are getting some peaks, and what he observed, elements with similar properties, they occupy at similar positions in the curves. Elements with similar properties, they occupy similar places in the curves. Okay. So, for example, if I take atomic volume versus atomic mass, if you plot, see here lithium, sodium, potassium, rubidium, cesium, all peaks are occupied by alkali metals. So, in this Lothar Meyer curve, peaks are occupied by alkali metals. Now, see here the descending portion of the curves, they are occupied by alkaline earth metals. See here beryllium, magnesium, calcium, strontium. The descending portion of the curves are occupied by alkaline earth metals, right. Now, see the ascending portion of the curves, they are occupied by halogens, fluorine, chlorine, bromine, iodine. Ascending portions occupied by halogens, noble gases. Descending portions are occupied by alkaline earth metals. The peaks are occupied by alkali metals. The troughs are occupied by transition metals. So, different places, different types of metals are occupied, right. So, maybe for bits purpose we require which position, which metals are occupying. See, but this alkali metals occupy the peaks, alkaline earth metals they occupy descending portion of the curves. Then halogens, noble gases, ascending portion of the curves. Then transition metals they occupy the troughs. Why this type of classification didn't work out? To memorize this many positions. See here. So, ascending portion which type of elements, descending portion which type of elements, peaks which type of elements, troughs which type of elements. To memorize this many different types of elements at different positions, it became a big problem. So, this type of Lothar-Meyer atomic volume curves, they didn't work out. Now, we are taking one more great scientist, Demerits of Mendeleev. He classified elements. He gave a periodic table. The main basis for Mendeleev's classification of elements is atomic mass, right. Atomic mass is kept into mind while classifying elements. So, he gave a Mendeleev's periodic law. What is this law? The physical and chemical properties of elements are the periodic functions of atomic mass. What is Mendeleev's periodic law? The physical and chemical properties of elements are the periodic functions of atomic mass. So, while classifying elements, he considered atomic mass as well as their properties also. Not only atomic mass, he kept in mind properties of elements while studying this table, right. In this table, if you observe, there are altogether, he gave a Mendeleev's periodic law. In this table, see, in any periodic table when we generally think, the horizontal rows are called periods, vertical columns are called groups. What is a period? Horizontal rows, they are called periods, vertical columns, they are called groups. See, Mendeleev called these horizontal rows as series. Series or periods, horizontal rows, vertical columns, they are called groups. How many periods and groups are there in this Mendeleev's periodic table? There are altogether 7 periods. So, in this Mendeleev's periodic table, there are altogether 7 periods and 8 groups in the original periodic table. In the original Mendeleev's table, there are 8 groups, but once noble gases were discovered in the year 1900, so they were also included here. So, in the modified Mendeleev's periodic table, there are altogether 7 periods and 9 groups. So, the first 3 periods, they are short periods. From 4th period onwards, 2 rows together, one series. First 3 periods, short periods. From 4th period onwards, 2 rows together, one series, like that he has classified. See, first 3 periods, short periods. From 4th period onwards, 2 rows together, one series. And coming to groups, 1 to 8, Roman number 8 in the original table, noble gases were discovered, added as 0 group. and each group has again subgroups A and B. So, this is about Mendeleev's periodic table. Now, what are the main features of this Mendeleev's periodic table, right? The main points in this table, see, he arranged elements in the increasing order of atomic mass, and he kept in mind properties of elements also. But while arranging elements in the increasing order of atomic weights, at certain places he observed that there is a decrease in atomic weight instead of increase. If I take for example argon, potassium, see here atomic weight 40, (40), 39. Instead of increase in atomic weight, there is a decrease in atomic weight. So, like this here and there at some places there is a decrease in atomic weight. For example, if I take tellurium iodine, I am writing here, we are taking tellurium iodine 128, 127. There is a decrease in atomic weight instead of increase, but he did not recorrect this one because he considered the properties also. Tellurium resembles oxygen family elements, oxygen, sulfur, selenium, tellurium. Similarly, fluorine, chlorine, bromine, iodine. So, see what happens, iodine atomic mass is less than expected, but he did not rearrange, he kept iodine under halogens. So, while classifying elements, Mendeleev kept in mind properties also. Since iodine resembles halogens, he kept them like that only. So, like that here and there in this periodic table, there are certain inverted pairs. Instead of increase, there is a decrease in atomic weight, that is called inverted pairs. What are these inverted pairs? Tellurium iodine, argon potassium. Now, what are other pairs? Observe here, cobalt nickel, 58.9, 58.6, slight decrease in atomic mass, thorium protactinium, 232, 231. See these pairs of elements. So, these are inverted pairs. So, the main features of Mendeleev's periodic table we are discussing. At certain places, when arranged in the increasing order of atomic weight, Mendeleev observed instead of increase, there is a decrease in atomic weight. What are inverted pairs in the Mendeleev's periodic table? Argon potassium, tellurium iodine, thorium protactinium, cobalt nickel. These are called anomalous pairs. What are anomalous properties? Anomalous, something different than expected. Instead of increase, there is a decrease, anomalous property. So, there are here and there 4 pairs of elements, anomalous pairs, right. So, we are discussing main features of Mendeleev's periodic table. See, when there is a decrease in atomic weight, he thought that first measurements might be incorrect, but he did not rearrange because he considered their properties also. Next, see Now, at some places Mendeleev observed certain elements. He is such a great scientist. See, generally whatever there in books we will study, we will do some experiment. But Mendeleev, he studied properties of elements which were not discovered at that time. He is such a great scientist. He studied properties of elements, undiscovered elements. He studied their physical properties like atomic mass, density, certain melting boiling points. He studied the properties of some undiscovered elements, but he could not name them. So, he left some gaps in the periodic table. Here and there some gaps he left, right. So, they are called missing elements, right. He named some elements as Eka boron, now it is known as scandium. Eka aluminium, now it is known as gallium. Eka silicon, now it is known as germanium. What are missing elements in the Mendeleev's periodic table? Scandium, gallium, germanium. The original names he predicted, Eka boron, now it is scandium. Eka aluminium, now it is known as gallium. Eka silicon, now it is known as germanium. So, certain places he left some gaps for the undiscovered elements, right. So, some physical properties of elements he even studied. See, for example, Eka aluminium, the predicted value, see here, Eka aluminium predicted value, atomic mass 68. What is the observed value? 70. Means for gallium, observed value 70. See, no need to by heart all densities, all values. Atomic mass of Eka aluminium and gallium. We will come back just within 2 minutes. Welcome back to our channel Vignan Junior Colleges. We are discussing classification of elements and periodicity in properties in this chemistry session. Till now we discussed different scientists, their opinions regarding classification of elements, right. So, this particular Mendeleev, we are mentioning certain main features of Mendeleev's periodic table. He left some gaps in the periodic table. He studied the properties of some undiscovered elements, right. For example, if I take Eka aluminium, atomic weight is 68, whereas actually found gallium value 70. See, no need to by heart all these density values and all, but we must know predicted value is slightly less. the actual value is slightly higher, maybe in objective bit, rarely he may get. So, predicted value is slightly less, actual value is slightly high. Similarly, density 5.9, actual value 5.94, slight increase in density. If I take for example gallium, see here, density is predicted value is predicted value 5.5, observed value 5.94. So, certain physical properties he studied some elements, but he could not name them. He left some gaps in the periodic table, they are called missing elements. What are missing elements in the Mendeleev's periodic table? Scandium, gallium, germanium, and not only that, here and there he left some gaps. Now, we are discussing main features of Mendeleev's periodic table. In this table, you know, elements in 8th group, 3 elements he kept as a row. For example, iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum, transition triad. In this 8th group, he placed 3 elements as a row, right. Now, what he observed, elements with dissimilar properties, but he kept together. For example, if I take in first group, for example, potassium, rubidium, cesium, they were placed with copper, silver, gold. Similarly, calcium, strontium, barium, second group elements, they were placed with zinc, cadmium, mercury. So, each group except 8th group, each group is subdivided into A and B. So, he placed elements with dissimilar properties together, right. So, these are some main features, and one more point to remember, he rectified atomic weights of certain elements like beryllium, indium, uranium. Certain elements atomic weights he rectified by using the formula atomic weight is equal to equivalent weight into valency. Equivalent weight concept we will be discussing in the further classes in stoichiometry chapter, second year solutions chapter. So, we are not touching much. Which formula he used to calculate these atomic weights? Equivalent weight into valency. So, he rectified atomic weights of some elements, right. So, these are the main features of Mendeleev's periodic table, right. So, then what are the merits or advantages of Mendeleev's periodic table? Just now we discussed. He studied the properties of some elements which are undiscovered at that time, right. So, he left some gaps in the periodic table, that is one merit, advantage. Next, he studied the properties of, he rectified atomic weights of certain elements, beryllium, indium, uranium. So, these are all merits or advantages of Mendeleev's periodic table. He rectified some elements atomic masses. Which formula he used? Atomic weight is equal to equivalent weight into valency. He studied the properties of undiscovered elements and left some gaps in the periodic table. Now, we are discussing some demerits, disadvantages, limitations of Mendeleev's periodic table. See, we see here position of hydrogen is uncertain in this periodic table. See here, if I take hydrogen, first group it belongs to lithium, sodium, potassium, rubidium, cesium, francium or something. Hydrogen is placed along with first group elements. For example, if I take, so hydrogen has 1 electron in the first shell, 1s1, right. Similarly, alkali metals 2s1, 3s1, like that. That means just like alkali metals, hydrogen has 1 electron in the valency shell. Similarity, hydrogen can form +1 oxidation state just like alkali metals. It can show +1 oxidation state. In certain properties, hydrogen resembles first group elements, right, but in some other properties it differs from first group elements. For example, if I take hydrogen is diatomic. What is atomicity? It indicates number of atoms in a molecule. Atomicity of hydrogen is 2, diatomic, whereas lithium and other alkali metals, they are monoatomic, right. Hydrogen diatomic, others are monoatomic. There is some difference between hydrogen and other elements, right. Similarly, hydrogen is non-metal, whereas all these first group elements, they are alkali metals. So, in certain properties it shows similarity with alkali metals, in certain properties hydrogen differs from alkali metals. So, its position is still uncertain, right. Hydrogen can also be placed under halogens. For example, if I take hydrogen, fluorine, chlorine, bromine, iodine. See, if I place hydrogen under halogens, in certain properties it resembles halogen. For example, hydrogen is gas like fluorine and chlorine. It resembles fluorine and chlorine because it is gas. Hydrogen is diatomic like halogens. 2 atoms in one hydrogen molecule, H2, like F2, Cl2, Br2. So, hydrogen is diatomic like halogens. Hydrogen, it can even show -1 oxidation state when hydrogen combines with certain metals, first group especially second group metals. Hydrogen can show -1 state because it is highly electronegative. Say for example, when I take calcium hydride, hydrogen is -1, lithium hydride, hydrogen is -1. So, just like halogens, what is the oxidation state shown by halogens? See, -1, common oxidation state. Halogens have 7 electrons in the valency shell. Instead of losing 7, they can gain 1. So, their common oxidation state is -1. So, hydrogen resembles halogens because it can show -1 oxidation state. Hydrogen is non-metal just like halogens. Hydrogen can show -1 just like halogens. Hydrogen is diatomic just like halogens. Hydrogen is gas just like fluorine and chlorine. So, certain properties hydrogen shows similarity with halogens. In some other properties hydrogen resembles alkali metals. The position of hydrogen is uncertain, that is in the Mendeleev's periodic table. We are discussing some limitations, drawbacks. Position of hydrogen is uncertain in this periodic table. Now, if we take other example, another drawback, limitation. See, isotopes are not accommodated in the main table. What are isotopes? They have same atomic number but different mass numbers. Isotopes of atoms of the same element. They have same atomic number, they have different mass numbers. When atomic number is same, means like properties will be similar, but their mass number is different. For example, if I take protium, deuterium, tritium, atomic number is same, mass number different, right. So, mass number means number of protons and neutrons, atomic number, it indicates number of protons. See, each and every element has different types of isotopes. So, to place all these isotopes, when they are placed in the main Mendeleev's table, everything will be disturbed, right. So, position of isotopes, they did not get a good position in this Mendeleev's periodic table. We are discussing some drawbacks, limitations of Mendeleev's periodic table, right. So, position of hydrogen uncertain, isotopes they are not accommodated in the main table, right. See, at some places instead of increase there is a decrease in atomic weights. See, for example, argon, potassium. See, we have just now discussed argon 40, potassium 39, tellurium 128, iodine 127, thorium 232, protactinium 231, cobalt 58.9, nickel 58.6. So, at certain places instead of increase in atomic weight, there is a decrease in atomic weight, limitation, drawback of Mendeleev's table. And here in every group dissimilar elements they are placed together, right. So, that means elements with dissimilar properties. For example, copper, silver, gold, first group elements, they are placed along with potassium, rubidium and cesium. See, dissimilar properties, elements are kept together in one group as A and B. For example, when I take like potassium, rubidium, cesium, they are soft metals and they are highly reactive, they have one electron in the valency shell, they are soft, highly reactive. If I take copper, silver, gold, we cannot cut with a knife under ordinary conditions, we cannot cut gold with a knife, but potassium, sodium, rubidium, we can cut with a knife. So, copper, silver, gold, they are hard, less reactive. Potassium, rubidium, cesium and other elements, more reactive. So, elements with dissimilar properties, they are clubbed together. And in 8th group, 3 elements they are kept together, elements with similar properties, transition triad, iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. So, 3 elements put together in one row like, so they are all kept together in 8th group. So, these are all some limitations or disadvantages of Mendeleev's periodic table, right. So, now we are taking now Moseley, one more scientist, he has done an experiment, right. So, what he did, he has taken a discharge tube, he kept so many elements in that discharge tube and he bombarded with cathode rays. What he did? He has taken an experiment discharge tube, he kept various elements, he bombarded with cathode rays, and what he observed, the X-rays which are emitted by these elements, there is some relation between frequencies of X-rays emitted and atomic number, right. What is Moseley observation? The X-rays which are emitted by these elements, there is a relation between frequency of X-ray emitted and atomic number, right. So, he has given a plot, he has drawn a plot by taking root nu, root of frequency of X-rays emitted and atomic number. He has drawn graph by taking root nu versus z, z indicates atomic number. So, he has got a straight line. If we take atomic weights, if we plot a graph by taking root nu versus atomic mass, so we are not getting such graphs, right? We are not getting straight line. So, Moseley he observed that atomic number should be the main basis of classification, but not atomic weights. So, he gave one modern periodic law. Moseley considered atomic numbers as the fundamental unit for classification of elements. What is modern periodic law? The physical and chemical properties of elements are the periodic functions of their atomic numbers. What is modern periodic law? The physical and chemical properties of elements are the periodic functions of their atomic numbers, right? Now, we will briefly sum up till now whatever we have discussed, right. So, we discussed different scientists, their opinion regarding classification of elements. Why do we need to classify elements? Because there are so many elements, 118 different elements are there in the periodic table. So, to study the classification each and every element, it is a difficult task. We require some systematic arrangement, right. So, we discovered, we just studied like genesis of classification, right. So, what is Dobereiner law of triads? Dobereiner he kept three elements as a unit or a group. He arranged elements with similar properties. What he observed? Atomic mass of the middle element is the average of atomic mass of terminal elements, first and third elements. But this did not work out for all other examples. So, this Dobereiner law of triads failed, right. Next, one more scientist Newlands, he gave law of octaves. What he observed? When elements are arranged in the increasing order of atomic weights, at 8th element, properties are similar to that of first element. There is a repetition of properties, similar positions, first element, 8th element, just like octaves of music, 8th note similar to that of first note. This holds good up to calcium, but once transition elements and everything kept together, so properties they are not matching. When once noble gas were added to the table, everything got collapsed because properties they are not exactly matching, right. Now, another scientist, two different scientists, they individually studied properties of elements. Who are they? Lothar-Meyer and Mendeleev. What is Lothar-Meyer's classification? He considered mainly physical properties of elements, but Mendeleev considered even chemical properties of elements also, right. Now, what are periods in the periodic table? Horizontal rows. Mendeleev called them as series. What are groups? Vertical columns in the periodic table, they are called groups. In the Mendeleev's periodic table, how many periods are there? There are altogether 7 periods. How many short periods? 3 short periods. From 4th period onwards, 2 rows together, series. How many groups are there in the Mendeleev's table? Originally there are 8 groups, but in the modified Mendeleev's table, altogether 9 groups including 0 group noble gases. Except 8th group, other groups are subdivided into A and B, right. So, what are main features of Mendeleev's table? He discovered properties of elements which are not discovered, but he studied the properties of undiscovered elements. He left some gaps in the periodic table. What are missing elements? Scandium, gallium, germanium. Next, what are inverted pairs in the periodic table? At different places he observed there is a decrease in atomic weight instead of increase. Argon, potassium, cobalt, nickel, tellurium, iodine, thorium, protactinium. They are anomalous pairs or inverted pairs. Next, whose atomic weights are rectified? Beryllium, indium, uranium and some other elements, their atomic weights are rectified. Which formula Mendeleev used? Atomic weight is equal to equivalent weight into valency. He used that particular formula to rectify atomic weights of elements, right. So, these are some. One more point is dissimilar elements are placed together, first group, second group. So, in every group certain elements with dissimilar properties are kept together. So, these are all main features of Mendeleev's periodic table. What are merits? He discovered the properties, he studied undiscovered element, he studied their properties, and he rectified atomic weights of some elements. What are disadvantages? Position of hydrogen uncertain. Position of hydrogen is uncertain. Then isotopes, they are not accommodated in the main table. Here and there, instead of increase, there is a decrease in atomic weights, inverted pairs, anomalous pairs. He left some gaps in the periodic table. He could not name the elements, but some elements he studied their properties, left some gaps, disadvantage. Elements with dissimilar properties kept together, disadvantage. And here 8th group has 3 elements in a row, not separate positions, not separate groups or columns, but they are all kept together in one group. So, these are all disadvantages. So, what is this Moseley? He said that atomic number should be the main basis for classification, but not atomic weight. What is modern periodic law? The physical and chemical properties of elements are the periodic functions of atomic number. What is Mendeleev's periodic law? The physical and chemical properties of elements are the periodic functions of atomic weights, right. In the coming classes, we will be discussing some worksheets we are sending to you, and tomorrow's class we will be discussing the worksheet and we will add some more points. And then before I start this long form of periodic table or Bohr's table, modern periodic table, right. So, today's class we have discussed a brief outline about classification of elements. So, how many gaseous elements are in the periodic table? Do you have some idea? 11 elements. What are they? Say hydrogen, oxygen, nitrogen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon. There are 11 gaseous elements in the periodic table, right. So, can you tell one liquid metal in the periodic table? Mercury, right, liquid metal. So, in the coming classes we will be discussing the long form of periodic table. So, in the next class we will be discussing the long form of periodic table. What are periods? The horizontal rows in the periodic table. What are groups? The vertical columns in the periodic table. What are periods? Horizontal rows. What are groups? Vertical columns. This is the modern periodic table. This is long form of periodic table, Bohr's table, and in this table there are altogether 7 periods and 18 groups. How many periods? 7 periods. How many groups? 18 groups are there in this periodic table. See, if I take for example, first element hydrogen. So, first period hydrogen and helium. Only 2 elements are there in the first period. It is the shortest period. Which is the shortest period in the periodic table? First period, hydrogen and helium. So, tomorrow we will continue and we will do some worksheet and continue this long form of periodic table. Thanks for joining. Please subscribe this channel.